Okay, now we proceed, okay, to the steps in mathematical modeling. The main idea is how actually can we transform, or can we explore the possibility for us to really make full use of the problem in hand. The problem in this sense is the real problem application, for example, real world application. Okay, and then how can we actually acknowledge that this problem exists, and how best for us to provide solution for this particular problem that we have. Okay, so you look at these steps, actually is a looping stage. All right, the looping stage. If let's say you have ample time, you can always keep on revisiting your problems, and then revisiting your model, and revisiting your efficiency, in a sense of analyzing effectively the final solutions, and then you come back to the original problem and re-emphasize and re-input, reintroduce another inputs, parameters of variables, and then keep on repeating the similar problems. Okay, that one is we call idealistic approach of doing things. Okay, the most ideal solution, but we know that we don't have that much time available for us, and our resources is also limited. So how best to improve this is that you keep on doing things, and once you think that as long as the measurement error, for example, is minimal, or the efficiency of your particular problem based on your solution is a little bit increase compared to the previous solutions, then you can stop. Meaning that you are able to offer a new solutions, a better solution compared to the previous solution. Okay, so how best to do this? All right, the first thing, you have the real world problem. Okay, that one is clear. What does it mean by real problem? Meaning that whatever problem that you have in mind, you want to reduce that. Okay, you want to understand more. Okay, it can be in a very technical things. For example, how you're going to see uh, the way fluid behaves. Okay, the way fluid behave. What do you mean by fluids? Fluids mean even the liquid is a fluids. The way your wind blows. Okay, why wind is very important? Okay, because you talk, when you talk about wind, yes, you feel, oh, I don't mind feeling the breezy wind next to me. Okay, but when you talk about wind in a sense of a turbulence, let's say you are in the airplane, now it is not that interesting anymore, isn't it? Okay, that's why we need to really understand the behavior of the fluid dynamic, for example. Okay, there is one problem, that one is very technical. They normally use with a lot of extensive mathematical formulation. There are lots of dy dx, dy d alpha, and so on. There are lots of kinetic, dynamic, and whatever name that you can find. Okay, and another way, there are also real problem that you can consider. For example, a simpler real problem that you have in mind. For example, how you want to make sure that you are able to make sure that your customer is happy. Let's say you want to build, or you want to open a restaurant, and then your intention is very simple. You want people to go to your restaurant, you want to give good service, and then they get what they want, and then they go out from your system. Your system, in a sense, is a restaurant right now. Okay, so the easiest way for you to know that your customer is happy, beside of the qualitative part meaning that you have a good staff that keeps on welcoming people with smile. Okay, but what you can measure, mostly normally people want to get the fast service as fast as they can, right? Especially if you are dealing with a fast food restaurant, all right? That what it means by fast food. Okay, you don't want to go to one restaurant, one fast food restaurant, but then you need to uh, take a long time for you to get your order. That is not fast anymore. It does not reflect on the restaurant itself. So, this is another way for you to model. We call that a queuing system. Okay, that one you can use a queuing system. It's not that complicated as how you solve turbulence issue. Okay, but still you can always use certain elements, all right? But this one, this certain element, you can start to look at it based on the observations, all right? You need to find the waiting time, and then you need to see how many people come into your system. Okay, system again in this particular area, your restaurant, and then how long one particular customer get what they want, what they ask of your services, and then you calculate based on this particular problem. All right, so that is another simpler kind of real world problem, but also solvable. All right, so once you have this particular problem in hand, okay, now your main intention is how you're going to simplify, all right, this particular real problem into another working model. Okay, working model in this sense is like a brainstorming of ideas. What is your input, what is your output, what is your main problem? Because if you don't do this, all right, you will get caught up with the overwhelming ideas. What is it that you want to study? All right, so that is the main problem. I also face it. Okay, because once if we are becoming too ambitious to want to focus on lots of things, okay, we forget that we don't have that much resources, and we don't have that much information to be plugged into our model, all right, to be plugged into what we can solve. All right, so that is the most important part. In this sense, this is where your brainstorming, you need to your brainstorming in this particular working model activity. All right, and then once you have at least a brief idea what actually you want to focus on, and then what are the variables or parameters that involve with this kind of particular working model, particular working model, then now you can represent your working model into a more structured mathematical model. Okay, normally in this case it is not just come out from nowhere. Okay, it's not that you simply sit down and then suddenly you get to that idea of constructing your working model into a mathematical model. Okay, it does not work that way. If let's say you find it difficult for you to come out with a mathematical model, that's fine. It's okay. That is normal. Okay. What is not normal is for you to be depressed and not do anything. Okay. That does not work. All right. What you need to do once you get to this stage, mathematical model, you can always refer back to whatever you have in mind, and plus whatever resources that you have. Okay, so we are very lucky to be here right now in this particular time, because your resources, your online resources is huge. All right, it's huge. Okay, there must be people who work at the similar problem that you already have. Okay, so basically what you need to do is you try to retrieve back all the information inside whatever resources, either in a journal form article or in a lecture notes or whatever. But once you have some sort of like a brief idea of what kind of model fits with your kind of real world problem, then you can dig down to the resources in a more extensive way. Okay, meaning that extensive way you can get the information from the books, or if you don't mind reading journal article, that also fine. But normally if you have a simple problem, then you should go back to your books. Okay, because books normally they start to look at the problem in a very elementary ways, whereas where you have a journal article, it is current, but normally the introductory level, they just keep it off, and they just share with you we call the extensive part of the modeling. All right, so normally you a little bit lost when you that's why you are a little bit lost when you when you read a journal article. Okay, so once you have this particular mathematical model, what's next? Okay, it shouldn't be just leave it like that, right? Okay, and if let's say you only have mathematical model, we normally call that as a theoretical background. All right, theoretical background, yes, it is good, but if you want to tie your theoretical background into a real world problem, you have to have certain adjustment to make sure that it is up to your problems. Okay, because people don't understand theoretical. Okay, people don't sometimes when you want to solve real problem, people don't even bother to want to know about the back story behind your analysis, right? Okay, so that is when you need to translate your theoretical mathematical model that you have into a more computational part, whereby you can start to ease up into real world more effortlessly. Okay, meaning that when you can compute certain things, you can improve your theoretical part into computation. Okay, wise. Okay, what does it mean by computation? Okay, it also has different kind of simplicity. Okay, it's either you can some people use numerical part. Okay, numerical analysis to translate your mathematical models. Okay, that is when you have a lot of data for you to play around with. Okay, some other people use uh, translate it into a model that is more understandable. Okay, and some other people use different kind of data, different type of data, and make full use. Okay, the adjustment. Okay, make full use of whatever software, for example, for you to ease up with your competition. All right, so um okay, there are plus and there are minus behind that, but that one is another story. Once you put, I cannot simply say that one computational model is enough for one particular mathematical model. Okay, and it is not that one method fits all again. Okay, everyone has individual way of solving it, but the methods is the framework is like that. All right, the framework is the same, whereas the way you solve the framework is different according to different real world problem that you have, plus real world plus mathematical model also that you have. All right, and then once you understand and once you start to know how to translate your mathematical model into a more computable ways. All right, and then you're going to simulate this. Okay, simulation is also another uh, a part of the story. Okay, when I say you simulate, meaning that you rearrange or you test. Okay, you do the back test, for example. That is another way of doing it. You do the back test work, keep on doing the same work, okay, for your mathematical model, and see whether okay, if I can say it clearly, the back test is for you to check whether your system is actually stable. What does it mean by stable? Whether if you do 10 times, 200 times, or even 10,000 times, the result would be slightly similar. Okay, that is when you know that your mathematical model and your computational model is stable. Another another way of looking at things is sometimes you can see the error. All right, if let's say you look at the error, some model your error is large. Okay, error meaning that you make adjustment there and then you see when you keep on doing things, sometimes your error is very small, but some other time your error is very big. Okay, large. If let's say your error is very large, there must be something not right somewhere. Okay, so you need to backtrack your record. You need to look back at the computational model, whatever mathematical model that you have, and then you tweaks a little bit there and then. Okay, this one I'm not talking about. If let's say you do the programming part, okay, that one is another story. That is another error that you that I think will give headaches to many people. But this one is focusing more on the model only. All right, and then when you simulate that, and then once you have your results, okay, how can you interpret your results in a meaningful way? That is also another story, especially now that we live in this current age, okay, where people keep on talking about data analytics. Okay, this is the thing for you to improve yourself upon. Okay, if let's say you already have your results and your conclusions, okay, the most important part for you is to interpret it in a more meaningful way. Okay, people does not care about your numbers unless when you talk about, let's say you are an analyst and then you talk to your another peer also an analyst, that would be fine. Okay, you love data, and then your peer also love data, but normally people don't bother much about the data. They want to know that whatever solution that you can provide, it must be back from the scientific matters. Okay, the way you analyze is based from sound judgment. But what they really want to know is, are they able to understand what is it that you're going to give them? Okay, your solutions. Okay, that what makes people that was different people. Okay, what makes people good in their work and what makes people cannot deliver what they want to say. Okay, so I hope you get why it is important to see these particular steps in modeling, and I hope you are able to really scrutinize these particular steps and really identify which part of it that you think you have problems with, and then try to rectify this accordingly. All right, so all the best. I'll see you guys in the next lesson.